Hello everyone, today will be a day where we go a little beyond the standards, because we will examine 3D printers that can process industrial type plastic and even metal. We will look at how these printers work and what can be done. A few months ago, I learned a company in Izmir offered printing services with industrial-type 3D printers. Norm Additve, affiliated with Norm Holding. I contacted them immediately. I said that I wanted to give you information about what can be done with this little-known technology and how industrial 3D printers work. Thanks to them, they did not disappoint me, and we prepared a very nice content together. First, we will watch my meeting with Mr. Senk, General Manager of Norm Additve. Here, he will tell us about Norm Additve and his work. Immediately afterwards, we will see how these industrial-type printers work and how three-dimensional prints can be made even with stainless steel material. Yes, here we go. Hello, Mr. Senk. Thank you very much, Norm Additve, for having me. First of all, I want to know this. When and for what purpose was Norm Additve founded, and in what field does it offer services? I would very much appreciate it if you could kindly inform me about this.
Tabii. Norm Additve, Norm Holding'in bir alt şirketi.
Of course. Norm Additve is a subsidiary of Norm Holding. We were established to serve our customers only in the 3D technology section. In fact, its establishment dates back to the beginning of 2021. Before my job here, I was working as the RG Center Manager of Norm Bolt at Norm Holding. And we had a simple FDM device that we used there. We started to get familiar with this technology there, and we saw that it really increased our production capabilities, at least in the laboratory environment. Then we started to examine this technology. We started working with many companies since January and had the opportunity to examine all technologies operating in the industrial field, especially with many technology developers. Afterwards, we decided to focus on this business, and the process of the establishment of Norm Additve began. We officially established our company in the month of October 2021. We officially and formally started our production activities in the month of October 2022, along with our machine orders, as well as facility construction, for example.
Which areas or regions do you currently provide more service to?
Currently, we mainly provide services to the automotive industry. In addition, we have productions in the aviation part and especially in the civil aviation part. Recently, we have been working extremely intensively on the medical side, and we mainly help our customers in the machinery manufacturing parts.
So, what kind of machines do you exactly have with your current capacity currently?
We also have a special track called sandblasting for surface smoothing in both plastic and sandblasting areas. We have an assembly workshop that we use to build very large models. We currently have a painting system that we put into operation this year. With this system, we can paint parts in many different color options on polyamide materials and resin-based materials.
Bu sene içerisinde Formlabs'ın bir
This year, we also included a high-quality SLA printer from Formlabs in our lineup. Here, we can produce transparent parts using resin, we can produce very flexible parts such as TPU, and we can make plastics that meet high engineering requirements, which we call the durability series, which can reach strength values that polyamide 12 cannot reach. In 2024, 3 laser systems and our metal additive manufacturing system will join our company. On the plastic side, we will also have 3 SLS systems that work with powdered plastic material but additionally melt with laser.
So how would you list the advantages and disadvantages of additive manufacturing compared to traditional methods?
We can say it in a way like this. The advantage is that you can get the part very quickly. For example, let me talk about a tool holder. Used in the industrial field, you can have these various tool holders made with different types of and specific CNC machining processes, and you have to design this specific manufacturing method within boundary conditions. When you do this, manufacturers usually give you a lead time of approximately 2 to 3 weeks. However, in additive manufacturing systems, you can have this in 1 day. I can say that the most important advantage is speed. Secondly, it offers flexibility in terms of design.
Size tasarım anlamında esneklik sağlayabilmesi.
As I just mentioned, in conventional production methods, the paths that the parts will travel or the routes they can cut are generally not very flexible due to machine capabilities. But such a situation is not the case in additive manufacturing. That's why you can show more futuristic approaches in your designs. Of course, in this way you can make both original designs, and by using some analysis codes you can also make lightened organic designs, which we call generative design. This, of course, provides a significant weight advantage in your parts and significantly reduces your overall part costs as it causes the use of less raw materials. In this regard, both lighter parts and cheaper parts can be provided to you by additive manufacturing. Of course, there is a misconception in the market about its disadvantages. 3-dimensional systems can produce whatever you design. This is actually a market misconception. Of course, you have to follow some rules when designing the joint or its parts. When this happens, there may be some disappointment. That's why we recommend that our customers consult us during the design process, and if possible, we would like to provide them with design services, because it is necessary to design with a good command of this technology. From time to time, part costs can become a disadvantage for our customers. But when you look at it in the long term, it actually becomes an advantage. I can explain it this way. For example, you have a piece that you obtained by casting. Although the prices you get from additive faith remain higher up to certain quantities, I give examples ranging from 10 to 15 pieces. It may be more advantageous for you, because you don't have to make a mold. But of course, if you want 100 pieces, 200 pieces, 300 pieces, or even more pieces, the price advantage of additive faith definitely disappears.
You just mentioned the design, and indeed they should actually get design support from us. Apart from this, as far as I know, a scanning service has now definitely also been included.
We have a 3D scanner. We use this scanning device for 2 purposes. First, we can take 3D measurements to prove the accuracy of the products we produce and present them to our customers in the form of reports. Another advantage is that it allows reverse engineering. For example, if a customer of ours has a part he uses but does not have a drawing and does not want to deal with it, or if he needs a vest part, our friends can scan the existing part and model it in the CAD environment.
Now, can we just take a closer look at these printers we mentioned, because I was really curious? Those watching were probably also wondering how the system worked. I would be very happy if we could see it. Yes, what raw material are we standing next to the machine processing right now?
Right now, Ken, we are next to our polymer processing machine. As I mentioned, this is HP's 5210 series. If our friends are perhaps curious, they can check the details on Google. This printer system consists of 2 parts. The first unit you see is the part where the writing process is carried out, and the part where the powder is filled, and the parts are removed, which we call the processing station.
Ana yazıcımızdan bahsedecek olursam,
If I talk about our main printer, which is the main device in our office, you see an exhaust pipe here. There is actually an air draft in that specific part, and it is used to cool down the writing pool after the writing of the materials is completed. There is an airflow there. I want to show you this immediately right now, and the inside of our machine. As you can clearly see from here, we have a dust pool right here. The various parts are located in this dust pool. This is actually a system formed by the sintering of powder. It's definitely a production system that I absolutely like. There is no laser or melting process. Only here there are infrared bulbs, as you can clearly see above, and this heats the powder bed and causes the powder to stick together a little bit. We call this sintering. We also have a specific printing module section here. What's done here is, as each layer is written, it moves left and right. There is also a special adhesive on this particular printing module. We call them agents. He sprays adhesive materials onto the dust. The part behind it instantly dries and heats the sprayed adhesive. We call this curing. This process is repeated constantly, and all the pieces you insert are written layer by layer. After finishing the writing, of course, it indeed gets hot here with the dust and particles. It is left here to cool for a certain period of time. Afterwards, the dust unit here is removed and taken to the processing station. At the processing station, we carefully and precisely remove our pieces from here, just like we remove cookies from a cake mold. Afterwards, we put the resulting powder into the internship after passing it through certain necessary stages. We can insert our cartridge here, turn it off, and then start production again.
Tuşumuzu takıp kapatıp tekrar üretimi başlatabiliyoruz.
Now, one of the points I noticed while visiting the facility was that you have many various types of equipment, such as devices here, and vacuum cleaners and other cleaning tools here. What do these do in the process in the facility?
These are, in fact, various models and brands of different types of vacuum cleaners, really. Special vacuum cleaners, most of which work with water. Since the raw materials we work with are always in powder form, there is a risk of self-ignition, and these dusts are also harmful to human health. That's why I give an illustration. For instance, if we are producing in one unit, we have to clean in 2 units in this scenario. That's why, using these special vacuum cleaners and equipment, our friends clean the main machines with great care before and after each production. Afterwards, they are responsible for ensuring occupational safety by cleaning the floors and windows in the facility. We also use masks all the time.
In this environment, there should be no dust anywhere.
No. For example, since we are not currently producing, we can travel around in this outfit. But when we produce, there are special clothes that our friends use. They wear them, such as special headgear, special clothes, special gloves, shoes. We have to ensure job security in this way.
Bu şekilde iş güvenliğini almak zorundayız.
Anladım. We are currently standing next to the machine that produces metal. You said that it can process aluminum and steel materials, right?
We have aluminum and stainless steel in this machine.
How does this machine work?
The working principle of this machine is different from the polymer system I just explained, but it also uses metal powders as raw materials. Here we have a printer section for metal powders on the polymer side. I also said that we have a section we call processing station. Here they are all located in the same unit. The areas on this side are actually the part we call the processing station. Here you both fill in your raw material and remove your parts from here after they are written. Essentially, the operator comes here and there's a special system we call the recorder that spreads the powder. He's carefully making his arrangements. He meticulously adjusts the printing plates on which the parts will be printing. Then this part essentially moves from below and basically comes to the production section you see here. There are currently 2 400W lasers working in this production section, and you also make your designs on the computer. You give your printing data there here. First of all, there is a procedure that we call inertization. Because let's give an example. For instance, aluminum is a highly reactive powder. It should not be together with oxygen. We use nitrogen gas in our own machine. An oxygen-free environment, which we call inortization with nitrogen, is created. Then the song printing begins. Printing goes like this. First, the pieces are divided into slices in that slicing program. While writing each slice, the laser processes along the cross-sectional area of that slice and melts that powder area. Afterwards, the system we call recorder puts new dust on it once again. The laser carefully and meticulously finishes the process by precisely writing the new slice on top and adding it to ensure accuracy. After the process is fully completed, this part is actually inverted this time. And from here, the print pieces gradually rise from the dust. After this, our operator friend comes and first thoroughly and carefully cleans the parts from dust. It has a very long workmanship. While doing so, since he does not have any contact with oxygen, he has to work from the outside by inserting his hands through this part. Finally, after all the parts and dust are carefully removed, our friend then takes the parts out by thoroughly opening this cover and using a special elevator system, and our process is finished.
After the process here is finished, it seems like separate processes are applied to both plastic and metal. In other words, there are subsequent processes such as heat treatment of the metal or sandblasting the surface of the plastic. Actually, I really want to talk about both. For example, you took the plastic parts and they come out of that pure white powder. The next step is sandblasting.
Now, when we print plastic parts, they are not pinting with the support structures we call support. That's why you can only remove individual parts. And since those parts are hot, some of the dust sticks to the surface of the parts. Our friends are sandblasting to remove it. The sandblasting process is as follows. Very small ceramics or glass marbles are applied under pressure. They are sprayed piece by piece. After you perform this process, that residual dust on your parts is removed. At the same time, you increase the surface quality of the parts. Now, it's a little different with metal because there is no question of the pieces floating in the air. That's why you have to fix the parts to the plate you produce with structures we call supports in order to... After these, there are typically cutting processes, not always, but in most operations, when you are cutting these support structures directly, you may experience mechanical distortions in the parts. In order to avoid this, we subject all of our parts to heat treatment to ensure proper processing. In this way, support dismantling becomes easier and we increase the ductility of the parts to some extent.
Mr. Senk, thank you very much again for the information you provided. I think it is an extremely useful, detailed, and valuable video, and we can give the viewers a clear and comprehensive idea about the use of these printers in the industrial field. Thanks again for having me. It's truly an amazing technology. I already knew how industrial 3D printers work theoretically, but it was a very nice experience for me to go and see it on site and examine the products. Frankly, I can say going beyond the limits of desktop 3D printers has broadened my horizons. Unfortunately, it was not possible to show you the materials printed in the factory in close detail and explain what they are used for, because they are very serious about privacy. So much so that under normal conditions it is forbidden to even take photos or videos in the factory, but I at least borrowed many of the materials they printed as examples to show you. I can say that I am amazed by HP's multi-jet fusion technology. It is a great thing that all of the industrial type parts you see now can be printed without support. Thus, the user is almost not restricted in terms of design. Much more complex structures and futuristic designs can be made simply. This is a form of print beyond both FDM and SLA. Of course, as someone who has printed figures and hobby pieces in my review videos for years, I couldn't help but ask. I said, don't you ever get curious and print fun things? Of course they did. They worked on very small and detailed miniatures. They made a phone holder that can easily be added or removed like Lego bricks or in the shape of She-Hulk. Now you can see it very closely. As I just said, no support was used in any of these prints. It definitely caught my attention. Even the tiny dots at the end of his hair appear very clearly. What you see is a Rubik's Cube. There are very fine, intricate, and complex details and intricately designed organic parts on it. What's here? One benchy boat model. I think our video would be incomplete if we didn't see this model. In addition to the bench boat, flexible parts and moving parts, I also really like the fact that its entire system is active like an original Rubik's Cube. I think I won't leave this piece behind. There was a guitar in Mr. Teng's room. I loved its design. I've made a guitar before too. I also presented this to you as a project. I liked the result when I first made it, but after seeing this guitar, when I put it next to the one I made myself, it looked like a toy. These are metal samples in the pieces you see. The sensitivity of the laser is very high. You can see this very clearly in this horse model made for show purposes. It looks like it's seemingly made of thin wires. There are also quite numerous, extremely small and sharp points on the small test piece. There are very small holes. The device can easily do all of these. Don't take my word for it that you can do it easily. You have seen how serious and lengthy the preliminary preparations and post-processing processes are. You may have noticed the surfaces of the prints coming out of both printers are textured. It doesn't look bad. It added a nice atmosphere. Depending on the structure of the model, it may also be possible to make it smooth. That's all I have to say about industrial printing technologies for now. I hope the content was as useful to you as it was to me and that you enjoyed watching this video. So what are your thoughts about this technology? I'm waiting for your comments below. May your printer be trouble-free and your prints perfect. See you in the next video. Goodbye.